Welcome to ATS Academy YouTube channel. In this section of my YouTube lecture, I will examine unbalanced transportation problem using northwest corner rule. If you are coming across my lecture for the first time, please like the video, also share it with others. If you are a returning subscriber, I say thank you for being part of this channel. Unbalanced transportation problem. Unbalanced transportation problem is the one in which the total supply or the total demand is not equal to the total supply. The demand is not equal to supply. E.g., let us assume you have, let's say, A, B, and C. We have P, we have M and N. Demand, you usually have demand here and supply here. So you may have the cost of transportation. Let's say the cost is 3, 2, 5, 1, 4, 3. If the supply is 30, 20, this will be totaled 50. Supply is 50. Then demand, maybe let's say 10, 15, then 15. 10 plus 15, that is 25. 25 plus 15, that is 40. So in this case, the demand and supply are not equal. The supply is greater than demand. This is an example of an unbalanced transportation problem. To solve problem involving unbalanced transportation problem, the first step, step 1, you add dummy with zero cost. With zero cost of transportation. That is step 1. You add dummy to it. In some cases, in some problem, it may be added horizontally. In some problem, it will be added vertically. Now, you know here, demand, supply is greater than demand. In this case, supply is 50, demand is 40. Supply is greater than demand. So, to introduce dummy here, you will need to add dummy. Dummy is 10. You know it is 10 that will be added to 40 to make it 50. You are adding your dummy here. So that means you are introducing it vertically. So the new table will now appear just A, B, C, dummy, and supply. Then we have M and N. No, supply 30, 20, 50. 30. So 30 and 20. 30, 20. Total is 50. Demand 10, 15, 15. 10, 10, 15, 15, which is 40. Then that means dummy will be 10. That is the difference between 15 and 40. That is 10. So the cost, you know the cost of this is 3, 1, 3, 1, 2, 4, 5, 3. Then the cost of dummy will be zeros. So that is the step 1. Step 2, you solve the transportation problem using the method I've explained in my earlier video using northwest corner rule. Northwest corner rule. Illustration 2. Where demand is greater than supply. Remember, in this illustration 1, supply is greater than demand. Now, I want to retain the 40 we have as demand. But in place of supply, which is 30 here, let's have it as 15. So if you have this as the supply, if you sum up the supply, the total supply will be 15 plus 20, which is 35. So in this case, demand is greater than the supply. Demand is greater than supply. So you will need to introduce dummy to make it balance. Where will your dummy be added? So you need additional 5 here. Additional 5 here to make this total equal to 40. So that means you are introducing your dummy horizontally like this. When you introduce dummy, the table will appear just. You have A, B, C, and supply. Then we have M, N. I've told you your dummy will be added horizontally. So you will now have dummy. So your supply will have 15, 20. Then your demand, you have 10, 15, 15. And total demand is 40. And you want this to be 40 again. You know, this is 35. So you need to add 5 here. That is 40 minus 35. So that will give you 5. So the cost of dummy will be zeros, represented by 0. Then the cost of other items remain the same. 3, 2, 5. Then 1, 4, 3. 1, 4, 3. So the table will appear like this. Please, I will advise you watch my earlier videos on transportation for better understanding. So I will not repeat those steps explained in my earlier video, but I will give a comprehensive work example. Now let the question as work example. Keep watching. Example: unbalanced transportation, northwest corner rule. The Granite Gravel Company, GGC, has received a contract to supply gravel for 3 new road projects located in Ondo, Akure, and Owo. Construction engineers have estimated the amounts of gravel that will be needed at the 3 road construction projects. Project A, B, and C, location Ondo, Akure, and Owo. Weekly requirements. Truck loads 81, 142, total 223. The company has 3 gravel plants located in Idore, Ado-Ekiti, and Ikare. These 3 plants can supply the lorry loads of gravel required for the construction project. The company's chief dispatcher has calculated the amounts of gravel which can be supplied by each plant, and they are stated below. We have project P, Q, and R, location Idore, Ado-Ekiti, and Ikare. Amount available per week, truck loads 95, 85, 80, total 260. You are required to schedule shipments from each plant to each project in such a manner as to minimize the total transportation cost within the constraints imposed by the plant capacities and project requirements. The delivery cost from each plant to each project site are given below. To project A, project B, project C, from plant P, plant Q, and plant R. 5, these are delivery costs, 5, 11, and 6 for project A, project B, 8, 20, and 10, project C, 9, 16, and 21. Now, let's have the solution to this question. Let's set up the initial table. Initial table. We have to and from. We have project P, project A, project B, and project C. Project A, project B, project C. Then we have to and from. We equally have plant P, plant Q, and plant R. Plant P, plant Q, and plant R. Then, what are the costs of transportation? We have 5, 11, 6. 5, 11, and 6. Then, for B, we have 8, 20, 10. 8, 20, and 10. That is for project B. Project C, we have 9, 16, and 21. 9, 16, 21. Construction engineers have estimated the amounts of gravel that will be needed at the 3 road construction projects that will be needed. What will be needed is what will be bought. The amount of gravels needed is what they will need to buy. It's what they will need to purchase. That is talking about demand. So the demand as given, 81,142, total 223. So we have demand, we have 81 for A, 81, B, 100, B, 100, C, 42. Total is 223, 223, as given in the question. The company's chief dispatcher has calculated the amount of gravel which can be supplied by each plant, and they are stated below. Supplied. This is the amount that will be supplied for P, 95, for Q, 85, for R, 80, total 260. So we have supply. Supply P, 95, Q, 85, R, 80, total 260. P, 95, 85, and 80. This supply is totaled 260. You can see that the supply and demand are not equal. So, to solve this problem, the first thing is to make the problem balanced. To balance this transportation problem, that means we need to introduce a dummy activity. This supply is greater than demand. So you want what you have in this row to be equal to 260. You want it to be equal to the highest one. You always equate it to the highest value. That means in that case, to be equal, you will need to add the difference here, plus the difference here. So if you add the difference here, it will make the total equal to 260, not 223. So that means you are adding it this way. So you are adding it to the column. So now let's introduce dummy. Let me add dummy. So we have project A, project B, project C, àfilẹ̀kùn yẹn pariwo sí mi o. Ìyá ẹ̀ ò fẹ́ kó máa ṣílẹ̀kùn yàrá yẹn tó ṣí sílẹ̀ yẹn. Then project C, then we need dummy here. Dummy. Then we also need supply. Supply. Then we have 2 and from we have plant P, plant Q, and plant R. Plant P, plant Q, and plant R. Then we have the cost, 5, 11, 6. 5, 11, and 6. Then we have 8, 20, 10. 8, 20, and 10. Then we equally have 9, 16, 21. 9, 16, 21. Then supply dummy. I've told you that your dummy should be 0 cost. Your dummy should be 0 cost. Then supply 95, 85, and 80. Our demand, we have 81, 100, 42. Then the total of this 81 plus 100, that is 181, plus 42. This is 223. And the addition of this is 95 plus 85 plus 80. And this is 260. Now, to make it balance now, the dummy will be the total of this is 260. While the total of this is 223. So the difference between 260, that is 260 minus 223, that will give you the dummy value, minus 223. Then we have 37. That is the value of the dummy activity. Using the northwest corner rule, you start from the first cell at the top left-hand corner. So the first cell is this. So you make your allocation to that. Now, in this row, you have 95. In this column, you have 81. That means the maximum value that can be allocated to this is 81. So now, let's give 81 to this. So this 81 is cancelled. You'll be left with 0. If you remove 81 from 95, 95 minus 81, you'll be left with 14. Then, after that, you make the next allocation to the next cell, since you still have some value in this row. Now, you have 14 left, and you have 100 in this column. So that means you can give that 14 to this. The 14 is exhausted. If 14 goes out of 100, you'll be left with 86. 100 minus 14, that is 86. Then, no further allocation can be made. And no further allocation can be made to the first row since you have exhausted what you have there. And no allocation can be made to the first column since you have exhausted what you have in the first column. So now let's shift to this. You can't go back since you cannot make any allocation to this. So now you have 85 here and you have 86. That means you can allocate 85 here. 85 is exhausted. Then if 85 goes out of this, you'll be left with 1. No further allocation can be made to this row since you have exhausted what you have there. No allocation can be made to this column, but you can still allocate 1 to this column. Now, let's allocate this 1 you are left with. Let's allocate it here. The 1 is cancelled, you'll be left with 0. Then 1 goes out of 80, you'll be left with 79. So, you have exhausted this column and this column. Then the first 2 rows have been exhausted. Then here, you can only allocate 42 to this value. You can't allocate here and here since you have exhausted what you have in those rows. So you can allocate the 42 here. 42, then if you remove 42, you'll be left with zeros. Then 42 goes out of 79. 79 minus 42, then you have 37. Remember, no further allocation can be made to this column. No allocation can be made to the first and second row. So you are left with dummy. So that means you can allocate the remaining, since you have 37 left in this row and 37 in this column, you can give that to dummy here. So the 37 is going is 0, 37 is 0. So that means you have exhausted the whole truth system. So that is your allocation table using northwest corner rule. Now, what is the cost of transportation, total cost of transportation? Plan P to project A, 81. P, A, 81. And the cost is 5. 5 times 81. Let me say total cost. 5 times 81. Plus plan P to project B. That is 14. PB. And the cost is 8. Plus 8 times 14. That is for plan P. Then plan Q to project B, 85. Plus Q to project B. That is 85. 20 times 85. Because it's 20 times 85. Plus, we have plant R. Plus R to project B, 1. Which is 10 times 1. Plus R to C. R to C. That is 21 times 42. Plus R to dummy. R to dummy. And that is 0 times 37. But before I calculate the cost, I've told you the number of cells should be m plus n minus 1. That is the number of possible assignments. You want to know now your m, that is number of rows, or you can take it to the column, whichever one. Now let me have the number of columns or number of rows. Number of rows is 1, 2, 3. 3 rows. plus number of columns. Column 1, 2, 3. 3 columns. Dummy have to be excluded. Minus 1. 3 plus 3 minus 1. 3 plus 3 is 6. 6 minus 1, that is 5. Now, dummy will not be counted as part of it. Now, let's look at the number of assignments we've made. 1, 2, 3, 4, 5. 5 cells. That means it complies with the rule. Rule of n plus n minus 1. Now, how much is the cost of transport? 5 times 81. That is 405. Plus 8 times 14. 112. Plus 20 times 85. That is 1,700. Plus 10 times 1, that is 10. Plus 21 times 42. That is 882. Plus 0 times 37 is 0. Now, let's sum up everything. We have 405 plus 112 plus 1,700 plus 10 plus 882 plus 0. That will be totaled 3,109 naira. So that is the total cost of transportation. Total cost is 3,109 naira. This marked the end of the solution to this question. In my next video, I will examine unbalanced transportation problem using least cost method. Please make sure you like the video, subscribe to the channel, and also drop the love emoji. Thanks for watching ATS.